In this lesson, we are going to study about the trigonometric ratios on the right triangle. Here, the sides are angle. One of the angle are related here, and this is the reference angle for us. And this angle, it's theta here. With respect to theta, the side BC is opposite side name, and which has also one of the ray of the angle is called adjacent side, and hypotenuse is general name of the from the right triangle. Here we have the all ratios opposite over if I name as A, B, C the sides, A over B, A over B, B over A, C over A, and all these are here gives us the trigonometric ratios. Here trigonometric ratios it's giving. When you say sine theta, opposite side of the sine theta is sine opposite side over hypotenuse it means. So the length of opposite side over the length of hypotenuse gives us sine theta. Here for sine, cosine and tangent we have abbreviation form also. Sine, cosine, for sine, cosine, and for tangent we have abbreviated forms also. For sine, so, for cosine here sa, and for tangent this is toa. What does it mean, this so, sa and toa? Sine is opposite over hypotenuse. Sine theta is opposite over theta, opposite of theta over hypotenuse, sorry. And what about sa? Sa means cosine theta is equal to adjacent of theta over hypotenuse. Toa, tangent is opposite over adjacent. Let's continue. So these letters are the first letters of these equations. S-O-H, so. C-A-H here, sa. T-O-A, toa. It's continue. For remembering them, we can use also this one. What about the cotangent? Cotangent theta, it's going to be inverse of tangent, so it's going to be adjacent of opposite theta. Here we have secant and cosecant. We are rarely using these functions, so it's not going to be very important for us for the beginning. Later maybe in some operations we are going to use them. Okay, here we are trying to explain here the relation between the sides and angle and the triangle. Here unit circle. Here on the unit circle, when the hypotenuse is 1, when you divide the side by the hypotenuse, let's say this is sine alpha over 1, it's going to be sine alpha. So the length on the unit circle opposite side is sine alpha. The length in the unit circle which is adjacent is cosine alpha. So the coordinate also later we are going to learn sine over sine and cosine. Here when you change the angle, as you see, opposite side, it's the length of opposite side, it's not going to change. Again, it's going to be alpha here, and this is at the same time a over b, and the length here a and the length here c. Let's say a, the hypotenuse, it's not going to change, and it's going to be equal to b also. The sine value is a over b. It's going to be here by the similarity, sine alpha over 1, and again it's going to be sine alpha. Here, what I wanted to say, let me explain on these triangles. Now, here, if these two triangles are similar triangle, here the third angle, it's going to be beta, beta. All the angles are equal to each other, alpha, alpha, beta, beta, and 90 degree, and 90 degree, here it's going to be. So, here these triangles are similar to each other because angle similarity we have. If you want to find the value of x, if you use the similarity, you will do like this. X over 20, which means here opposite of alpha over hypotenuse is equal to opposite of alpha here, it's equal to 3 and 5. This is the first way, and I used here in the first way the similarity formula. 5x is equal to 60 it's going to be, and x is equal to 60 over 5. X is equal to 12. This is the first method to find the value of x by similarity. But we have the second method also here. The second method is related with the second way. We can use also the trigonometry. In the small triangle, sine alpha, which is opposite of alpha over hypotenuse, it's going to be. In the small triangle, sine alpha is equal to x over 20. And in the big triangle, the sine alpha is 3 over 5. As you see, x over 20 sine alpha and here 3 over 5, they are equal to each other. X over 20 can be written as equal to 3 over 5. And if they are equal to each other, 5x by the cross multiplication, 5x we should say it's equal to 60, and x is equal to 12, like this question solution, like this solution. Here the first way similarity, second way is trigonometric method, and in the exam, if both of them they are given, you may use which method you want, but generally we are going to give the questions in this form. Here now the sine alpha value it is given, like we have one small triangle in our mind, like alpha, and the opposite of alpha here 1, and hypotenuse is equal to 2. And we are going to relate this to triangle. With respect to the triangle, given triangle, the sine alpha, it must be opposite of alpha over hypotenuse, and it's equal to 10 over x. And in the question, sine alpha is given 1 over 2 here is equal to 1 over 2. From this 2, 10 over x is going to be equal to sine alpha. Another sine alpha here, it's equal to 1 over 2. So x times 1 is equal to x is equal to 20, it's going to be. Here if we continue, again, tangent alpha this time is given. Tangent alpha, we need to remember, tangent alpha, it was with 2a, if you remember, opposite of alpha over adjacent of alpha is going to be. And in the question, opposite of alpha is 15, and adjacent of alpha is equal to x. Here it is given tangent alpha is equal to 5 over 7 in the question part. So it means that 15 over x is going to be equal to 5 over 7. Then 5x is equal to 15 times 7. I don't want to multiply because I'm going to send this one as a division. X is equal to 15 times 7 over 5. When you simplify this 2, this is going to be 3, this is going to be 1, and x is equal to 21 over 1, which is equal to 21. If we solve another example for the cosine alpha, what was the abbreviation form for the cosine alpha? For the cosine alpha, sah it was, which means cosine alpha is equal to adjacent of alpha over hypotenuse. It was like that, and it's equal to adjacent of alpha here. This is adjacent of alpha, and over hypotenuse is 10 over x. It must be. And cosine alpha is given at the same time. Cosine alpha is given at the same time 2 over 3 in the question part. So it means that 10 over x, it must be equal to 2 over 3. 2x, when you cross the multiply, 2x is equal to 30. 3 times 10. X is equal to 30 over 2. X is equal to 15. It must be.